Hello. So today I am recording a video because it seems like you guys still need some additional help understanding the periodic trends. This was something that we talked about in class before the dismissal, but some of you guys may not have understood the Nearpod notes or may just need a little extra support with these periodic trends. So we're going to go through this presentation um, to help you understand this better and to help you on your retakes of the alien periodic table assessment. If you guys want to do that again, a lot of you guys are missing the part about the periodic trends. So I made this video to kind of give you some more information and to give you some more practice on this topic. So our essential question for today, what trends can we see on the periodic table? So one of the first properties we talked about was atomic radius. And atomic radius is defined as 1/2 the distance between the nuclei of two identical atoms. So if this red dot represents the nucleus or the center of an atom, and this is the center of an additional atom, these two atoms are the same. So let's say we have two hydrogen atoms, okay? If we measure the distance between these two nuclei, the radius would be 1/2 of that distance, okay? So we measure that in picometers, and this radius for this atom would be 180 picometers. Atomic radius is a way for us to determine how large or small atoms actually are. So what is the pattern that we're noticing here on the periodic table? Well, if you look at this chart, you can see that our largest atoms are found on the left-hand side of the periodic table. And as we go across each period, our atoms are getting smaller. This is what you guys should have seen in the simulation. But the pattern is that our largest atoms are on the left, and as we go across each period, the atoms get smaller. Now, what about going down each group? Well, as we go down each group, we're adding electrons, we are adding energy levels. So our atoms are actually getting bigger. So our biggest atoms are going to be in this bottom corner of the periodic table because our atoms get smaller left to right and bigger top to bottom. So this corner is going to have our biggest atoms, and this corner up here is going to have the very smallest atoms on our periodic table. That is the pattern or the trend for this property of atomic radius. So I want you guys to practice putting the following elements in order of atomic radius, largest to smallest. We have two practice problems. So I want you guys to see if you guys can order these elements: germanium, bromine, potassium, and selenium. The first thing you guys have to do is find the position of these elements on the periodic table. So here's germanium, here's bromine, here's potassium, and here's selenium. Notice they're all in the same period. So use this pattern to help you figure out which one is going to be the largest and which one's going to be the smallest. Okay. Then for number 2, we're going to do the same thing, only we're going to do this for our noble gases. Okay, our noble gases right here: argon, neon, xenon, and helium. So again, using this trend, I want you guys to put them in order of increasing atomic radius. So pause the video now to practice these two problems. All right, so let's check your answers to see if you got the right answers here. Number 1, our largest atom is potassium because it's furthest to the left. Our next largest atom is germanium, followed by selenium, and bromine because bromine is the furthest to the right. So if we put those in order, potassium's the largest, followed by germanium, selenium, and bromine because that's order of increasing atomic radius, largest to smallest. Okay, now let's look at number 2. Number 2, you should have ordered xenon as the largest because it's at the bottom of the the bottom of the group, followed by argon, neon, and helium is our smallest because again, this is on the bottom, this is on the top. So this is the largest, the next largest, and the smallest is helium because our largest atoms are at the bottom, our smallest atoms are at the top. So hopefully you got that one right. Okay, let's keep going then and look at another pattern or trend that we can see on the periodic table. The next thing we talked about was ionization energy. Ionization energy was defined as the energy required to remove an electron. So remember, an ion is an atom with a charge. In order to make something an ion, ions have to either be lost or gained. So if I remove an electron, that forms an ion, which is ionization, and the energy that's required to remove this electron is described as ionization energy, the energy required to remove an electron from a neutral atom. The closer to the nucleus that the electron is, the harder it is to remove, and therefore it takes more energy. Because the closer it is to the nucleus, the stronger the force of attraction. Remember, our nucleus is positively charged, our electrons are negatively charged. So the closer we get to the center, the more energy it's going to require to remove that electron. You can think of these protons like magnets. The closer we are to these magnets, the more energy it's going to require to remove the electron away from the atom. So here's our pattern. Notice it's the opposite of atomic radius, because our smallest atoms are going to have the highest ionization energy. Our highest ionization energy is going to be in this corner of the periodic table. Our ionization energy is going to increase from left to right across the periods, and it's going to decrease from top to bottom because our atoms are getting larger. Our electrons are getting further away from the nucleus. Okay, so again, I'm going to ask you guys to practice this, to pause the video and to practice putting the following elements in order of smallest ionization energy to largest. And again, you're going to do this based on the position in the periodic table. So let's look at our two practice problems. Our first one is magnesium, barium, calcium, and beryllium. So we're looking at this group 2. Okay, your job is to put that in order from smallest to largest ionization energy. Our second group of practice problems is going to be in the same row. So it's going to be fluorine, beryllium, nitrogen, and carbon, all here on our second period. Okay, and again, use this chart, use this pattern that you see here on the screen to help you put those in order. So go ahead and pause the tape, pause the video to practice putting those in order according to the trend. All right, let's double check your answers. Let's see if you got these ones right. Number 1, you should have listed barium as the smallest ionization energy because it's at the bottom of our group. It has the lowest ionization energy. Followed by calcium because it's further up, magnesium, and then beryllium. Beryllium is going to have the highest ionization energy because it is the smallest atom. It is going to have the most energy required to take away an electron. Okay, now let's order according to the period. Okay, and again, we're going from smallest ionization energy to largest ionization energy. So let's look at the smallest ionization energy is going to be beryllium because it is the largest atom in this period, followed by carbon because it's further to the left, followed by nitrogen. Fluorine is going to have the highest ionization energy because it is the smallest atom. The electrons are closest to the nucleus, so it's going to require the most energy to remove those electrons. So double check this order to make sure that you got that pattern right. All right, let's look at our next periodic trend. Let's look at our next property. Our next property is called electronegativity, and the definition of electronegativity is an atom's ability to attract electrons. So you can look at this little cartoon and you can think about why certain atoms would have a higher tendency to attract electrons than others. This is particularly true in compounds. So in general, atoms that are more reactive, that want to gain more electrons, are going to be more electronegative. That's why we see this top right-hand corner have higher values. If we look at the numbers, these elements in red, they're going to be more likely to attract electrons to become stable. And the metals over here on the left are going to have lower values. These ones in gray are going to be less likely to attract electrons. Okay, remember helium is a nonmetal, so even though it's on the left, it behaves more like these nonmetals over here. So again, here is the pattern. As we go across the periodic table, electronegativity increases. Our atoms are getting smaller. The attractive force of the nucleus is getting larger. So these atoms here in the top corner are going to be the most electronegative. As we go down each group, our electronegativity is decreasing. It's getting lower because these are larger atoms with more electrons shielding our positive nucleus, and those electrons are further away from the nucleus. So it increases left to right and decreases top to bottom. So again, I'm going to give you guys some practice problems. I'm going to ask you guys to pause the tape, to pause the video, use this chart, use your knowledge of the trends to help you order the elements from largest to smallest electronegativity. So our most electronegative elements are going to be in this top right-hand corner. Our least electronegative elements are going to be in this bottom left-hand corner, okay? So pause the video for just a second and see if you guys can put those in order from largest to smallest electronegativity. Our first elements are nitrogen, antimony, phosphorus, and bismuth. So we're looking at this group right here, group 15. Then across the period, we're looking at these elements, strontium, Sr, iodine, tin, and tellurium. So these period 5 elements, okay? So put the elements in order from largest to smallest according to the trend you see on the screen. Pause the video and practice those problems now. All right, let's double check your answers. So for number 1, our largest electronegative element in this group is going to be nitrogen because it's closest to the top. Phosphorus is going to have a smaller electronegativity. Antimony is going to have even less electronegativity, and bismuth is going to have the smallest electronegativity because it's on the bottom of our group. So when we put them in order from largest to smallest, nitrogen is at the top and bismuth is at the bottom. Okay, for number 2, when we are doing it left to right with the 5th row elements, iodine is going to have the highest electronegativity, followed by tellurium. It's going to have a little bit less. Antimony is going to have a little bit less, and our least electronegative element is strontium over here on the left. Okay, so again, you use the chart, think about what's happening left to right, top to bottom, to put those elements in order from largest to smallest. So another thing that we can talk about is the reactivity of the elements. Reactivity is the tendency of a substance to undergo chemical reaction, either by itself or with other materials, and to release energy. So this trend depends on if it's a metal or a nonmetal. For our nonmetals, we ignore the noble gases because they are inert. They do not react with other elements. They already have a full outer shell of electrons, and so they don't react with others. Okay, so ignoring the noble gases, here's the pattern. As we go across the periodic table, our more active metals are going to be on the left, and our nonmetals are going to be more reactive as we move to the right. So you have to think about this as sort of 2 halves of the periodic table. It increases for metals as we go to the left, and for nonmetals, reactivity increases as we go to the right, which means that the halogens, starting with fluorine, is our most reactive element, and our most reactive metal is francium. So our metals get increasing reactive as we go down the periodic table. We saw that with the alkali metals and water. Francium is our most reactive metal, and fluorine is our most reactive nonmetal. So our reactivity increases from left to right and increases to the top for fluorine. For metals, it increases as we go towards this corner. Okay, so just know that there's sort of 2 different patterns based on whether it's a metal or a nonmetal. It says put the following elements in order of smallest to largest reactivity. So here is our metal group, and again, they get more reactive as we go down the groups. Here's our non-metal group. Remember, they get more reactive as we go up the groups. So take a moment and look at these 2 groups, our metals and our non-metals, and put those in order of increasing reactivity. Okay, let's check your answers. For our metal groups, our metal reactivity increases as we go down each group. So if we go down group 2, magnesium is our least reactive metal. Calcium's underneath it, so it's a little bit more reactive. Strontium's underneath calcium, so strontium's a little bit more reactive. And barium is our most active group 2 metal. If we look at our trend for our nonmetals, it increases left to right. So in the same period, carbon is going to be our least reactive nonmetal. Nitrogen's a little bit more reactive. Oxygen's a little bit more reactive. And our most reactive nonmetal is fluorine in our halogen group. So hopefully you guys got that pattern right according to the trend that you see here on your periodic table. So in summary, these are all of the trends that you guys need to know and be familiar with. Okay? When we started with atomic radius, we know that our largest atoms are going to be in the top left-hand corner because atomic radius decreases left to right and increases top to bottom. For ionization energy and electronegativity, the pattern is the same. It increases left to right and decreases top to bottom. For metal reactivity, there's two different patterns, a pattern for metals and a pattern for nonmetals. Our most reactive nonmetals are in this bottom corner with francium, so it increases top to bottom and decreases left to right. And the pattern for nonmetals, these blue elements, is that our reactivity increases from left to right and decreases top to bottom, with fluorine being our most reactive nonmetal. So hopefully this trend helps, this picture, this diagram helps to summarize those trends that we've learned. And hopefully this video helps you guys to understand the periodic trends just a little bit better. All right, here is a short video you guys can look at on YouTube. It's called 5 periodic tables that we don't use and 1 that we do. There's also videos on the SciShow about the 4 newest elements. And our final video here is 8 lesser known important elements, okay? These are fun videos to check out to give you more information about the periodic table. And hopefully this presentation has helped you learn more about the periodic trends. Have a great day.